Hello everyone, and welcome back to Jamnik Science. Today we are diving into a fascinating problem that involves the dimensional analysis to determine the unit of constant in physics equation. We are simply going to explore the equation V, which is equals to AT to the power of 2 plus BT plus C, and in this case notice that the V simply stands for the velocity and T, which is time. What we need to do is to simply take a step-by-step approaches, and we are going to figure out the unit of the constant A, B, and then the C. Let's assume we are given this kind of problem which says a given formula is derived from the velocity of an object V, which varies with time expressed as V, which is equals to AT to the power of 2 plus BT plus C, where velocity V and time T are expressed in terms of SI unit. What they ask us to do here is to determine the unit of the constant A, B, and C in the given equation. So how can we solve this problem? To determine the unit of the constant A, B, and C in the equation, we need to ensure that each time, when we talk about time, first let's write the equation first. The equation is given to us as velocity, which is equals to AT to the power of 2. We're going to plus that by BT and plus C. This is our first term by our right hand side, second term, and this is the third time, and this is right hand side, and this is left hand side. We need to ensure that each term on the right hand side of the equation has the same unit as the left hand side. Do you understand? So we can also choose to put it differently by saying we can also use the dimensional analysis, this method, to ensure each term in the equation is consistent dimension. For example, since let's say we are given velocity, right, which is from the left hand side, velocity which is being denoted by V, and velocity, dimensional analysis for velocity is going to be LT minus 1. If you could remember, we said velocity is what? Distance divided by time, and distance is measured in length, and time, which is T, we bring it up here, which is going to be LT minus 1. So this is the dimensional analysis for velocity. What about time? Time is being denoted by small letter t, and the dimension for time is going to be denoted with capital letter T. So what we need to do is to analyze each term. So for the equation to be dimensionally consistent, each term on the right hand side must have the same dimensions as velocity. And we said velocity is simply going to be LT minus 1. So we're going to start from the first term by the right hand side. So by the right hand side, our first term is going to be AT to the power of 2. So let's underline that and work on that. So what do we need to do? Let's pick another color. Acceleration, which is A, and here we have T to the power of 2, which is time. A in bracket, and let's put our T to the power of 2. And this must be equal to our velocity. So what you need to do is to substitute with the unknown dimensions, the dimensions which you know. So the dimensions which we know here is for the time. A is still unknown. We're going to multiply that by, instead of small, a t is going to be capital, and our velocity is going to be LT minus 1. So for us to find the dimension for A, which is going to be LT minus 1, we're going to divide that by T to the power of 2. Remember, this is 2. When it comes here, it's going to come with negative, and this is going to change from 1. It's going to change. 1 plus 2 is going to be 3. Therefore, our A is simply going to be LT minus 3. And this is for the first term. What about the second term? The second term is given to us as BT, isn't it? And BT must be equal to velocity. This is simply as saying bracket of B bracket of T must be equal to the bracket of V. And bracket of B into bracket of T must be equal to LT minus 1. So we already know the known value here, which is T. B is unknown. B is going to remain inside the bracket, which we are going to have left with LT minus 1 divided by T. If this come up here, 1 plus 1 is simply going to be 2. Negative 1, negative T, negative T is going to be 2, isn't it? So for B is simply going to be LT minus 2. Remember, for A, LT minus 3, for B, LT minus 2. So the last but not the least, which is the third term, which is C. Since C must be equals to V must be equals to C, and C must be equals to V, remember V is LT minus 1. So in this case, we can finally conclude and say, for A, let's use another color. For A, the answer is going to be LT minus 3, and the unit is going to be meter per cube. And for B, it's going to be LT minus 2, and this is going to be meter per second. And for C, this is simply going to be LT minus 1, which is meter per second. And this is meter per second square. So this is it for this problem, and I hope you find it helpful. Please, if you do, don't forget to just do me a favor by subscribing to Jamnic Science. Thank you, and see you next time.